Hey there. I've been getting a lot of questions lately about how to simplify radical expressions, things under a square root when you encounter them in a problem. So I figured let's do a quick review of it. Okay, let's take a look. So let's say in the middle of your problem, you find the square root of 1260. And you're like, what do I do with it? Okay, so here's how to simplify a radical. The first thing you have to do is you have to factor this number. You have to break it down to its component parts. So there are any number of ways to do this. As soon as I see a 0 on the end of that, I know there's a 10 in there, so I'm gonna just grab that out, and then I know that 10 factors to 2 and 5, and when I hit a prime number, a number that can't be divided any further, I circle it. Okay, so back to 126, I see in here there's a 2 for sure, so I'm gonna break that apart. And I see that 63, and I know that's made up of a 7 and a 9. And by the way, if you didn't see that 63 is made up of 7 and 9, please review your multiplication tables. It is never too late to master those, and it makes life easier. Whoops, and I circled that 9, which is erroneous. So I know that 9 breaks down into a 3 and 3. All right, so now I've got all of my component factors, and I'm going to pop those back under the radical. And here's how the simplification works. Square root asks the question, what times itself? So anything where I have a double factor, I can remove that from under the square root, both of them, and put it outside the square root as a single factor. So for example, I see here at the end 3 times 3. Well, the square root of 3 times 3 is just 3. So I get rid of those 3's and a 3 comes out. And I see I have a 2 times 2. So the square root of 2 times 2 is just 2. I cross those out and I take a single 2 out. And whatever I have on the outside is being combined by multiplication. Now, under the square root, I have left only a 5 and a 7. Those are not doubles and they don't break down any farther. And on the outside, I have a 2 times a 3. So the final simplification is 6 root 35. And that's how I would simplify that. Okay, let's do another one. All right, let's say I've got the square root of 675 plus the square root of 147. All right, let's start to break those apart. 147, I see there are sevens in all this, right? 14 has a 7, 7 has a 7. So I'll start by breaking it down that way. And then I see that 21 is 3 times 7, and all of those are broken down. And I'll work my 675. I see it ends in a 5, so I know a 5's in there. I see it ends in a 5, another 5's in there. My 27 breaks down, and my 9 breaks down. All right, so now I'm going to rewrite these radicals in their broken down form. And now I'm going to remove pairs on the inside to put singles on the outside. So a 5, 2 come out to be a 5, 2 3's come out to be a 3. And because that's so ugly, I'm going to rewrite that right now. 3 times 5, 15 on the outside, and inside I only have a 3, plus 2 7's come out. And so that's all right, so that's a 15 root 3 plus a 7 root 3. Okay, so we actually can move forward here. Students often sort of freak out. What do I do with this? I like to apply cow math. So pretend this scary root 3 is actually a cow. And if you have 15 cows plus 7 cows, how many cows do you have? That's right, you have 22 cows or 22 root 3's. Cow math, people, it's a thing. It just helps when there's something really scary to instead put in something really mundane. It helps you understand why the concept works. Alrighty, so this horrible looking problem simplifies into this rather concise little answer. All right, so take a look at my videos using the quadratic formula because often the end of the quadratic formula winds up having to simplify something. Take a look at some of the factoring videos, the ratio videos, and as always, keep on mathing.